Hey guys, we are on Unit 10 and we are going to be talking about coordinate geometry. So a lot of what we do will be on graphs. We'll use the coordinates to calculate some things. So like for instance, slope. If we wanted to find the slope of a line on a graph, how much it's tilted, we have a formula for that. But before we do that, let's do a little warm up from algebra. And it says write a linear equation for the following. And so we're going to have to do some review, especially because of last year being cut short. Not quite sure how much you guys learned about the equation of a line. But you've been doing equation of a line, I believe, in 8th grade and now in 9th grade and now again in 10th grade. So hopefully you are familiar with the word undefined slope. And we have a little acronym, right, to help you better understand lines that have something called undefined slope or zero slope, and that little acronym is called Hooy-Vux. All right, Hooy-Vux. So what this stands for is that the H stands for horizontal. So the Hooy part refers to any line that's horizontal, okay, that's going across for your paper from left to right. Those horizontal lines have what they call zero slope, and the equation of all horizontal lines is y equals a number. Okay, so if you type in your y equals 7 and you hit graph, you'll get a horizontal line that has zero slope. Whereas Vux refers to vertical lines that go up and down. All vertical lines that go up and down have something called undefined slope. Okay, and their equation of every single vertical line is x equals a number. And I would show you that in your calculator, but you don't have an x equals button, and it is impossible to graph a vertical line in your calculator. Okay, so that's the little acronym to help you remember, or some people will call it a mnemonical device, okay, that helps you remember something. So in part A, when they're talking about undefined slope, we know that they're talking about vertical lines, okay? And all vertical lines have an equation of x equals a number. So as soon as you know it's a vertical line, or as soon as you know that it has undefined slope, which is a vertical line, we write down the equation, which is y equals a number, and then all we have to do, x equals a number, and then all we have to do is find that number. So the cool thing is, because you know that it's x equals, you go to the point that it passes through and you look at the x coordinate and there's your number. So it's very, very simple. And all it is x equals -5. And that's the equation of a line that would have undefined slope and passes through the point -5, 3 on your graph. Okay. All right. So part B says perpendicular to the y-axis. So if we think about our graph, where this is the y-axis, okay, it's vertical. But if you were to draw a line that's perpendicular to the y-axis and passes through the point, let's say 712, okay, perpendicular to the y-axis means that you're making a right angle with the y-axis. And so you end up with a line that goes from left to right, which is horizontal. And so now we're thinking about Hooy. And remember that when we talked about Hooy up here, that all equations that are horizontal, that equation is y equals a number. And as soon as you know the equation, all you have to do is find that number. And the cool thing is, because you know it's y equals, all we have to do to go to the coordinate and look at the y coordinate this time, and it's 12, and that's your number. And so your equation is y equals 12. Okay, pretty simple. All right. So just think about what direction your line is going in. Think about whether you're talking about Hooy or Vux. Think about whether the equation is y equals a number or x equals a number, and then go find that number. Okay. Whereas all equations that are not horizontal or vertical have a slope that's not undefined or zero. And in that case, we have a slope formula that will calculate what our slope is, or how much a line is tilted. Okay, it's also known as rise over run. And up on top, guys, in the slope formula is the y's. And a lot of people messes that up because y alphabetically comes second. And so a lot of people want to put the y's on the bottom. So my little saying is y's to the sky. So you can remember that the y's are on top for the slope formula. All right. Lines not only have a slope or an m, but they also have a y-intercept, also known as the letter b. Okay. If your y-intercept is ever missing, the cool thing is, if you know your slope and you know one coordinate, an x and a y, you can replace the y, the m, and the x, and then you can solve for b, and you can find your y-intercept. Okay. Once we have the slope and the y-intercept of a line, then we can go ahead and write the equation of the line by taking out the m and taking out the b and putting in what you found from the first and the second part. Okay. All right. So that's what we're going to do today. All right. So it's not really new, but We haven't done it in a while, so it probably will feel pretty new. Okay? So in number 1, it says for the following pairs of points, we're going to graph the points and connect the points, and then we'll find the slope of the line. All right. So we're going to give ourselves a little bit of a visual by using the graph. And so A is at -1, +5. And B is at +3, -1. And if we were to connect that line, or connect the points and make a line segment, okay, or a line, because we can extend it through the points to make a line that goes on forever. But we're going to figure out how tilted that line segment is, which is really the slope, okay? And we could do a couple things. We could do something called rise over run, okay? Or we could go ahead and calculate the slope using the formula. So there's 2 ways to calculate slope. I prefer you guys use the formula since we are really good at using formulas by now. And that formula, guys, is m equals y2 minus y1 over x2 minus x1. Okay, and some people will come up here and label their x's and their y's. So for instance, they'll call this x1, they'll call this one x2, they'll call this one y1, they'll call this one y2. All right, and then all we have to do is plug them in. So we're going to end up with a -1 minus 5. All right, so because we chose to subtract the y's in that order on the top, we have to keep the same order for the x's on the bottom, and we have to do the 3 first, and then minus the -1. Okay, be careful and make sure that you have the minus signs in the middle here from the slope formula, but then your x coordinate here was also negative, so that has to be, so make sure you have all your negatives accounted for, okay? Nothing can disappear. All right, so all we're going to do now is clean up the top, and so -1 minus 5 is -6. And then on the bottom, 2 negatives in a row like that make a positive, and 3 plus 1 is 4. Okay. Slope must always, always, always be reduced. And so we're going to reduce this. You can use your calculator to reduce it. If you type in -6 divide by 4 and hit enter, it'll turn it into a decimal, and then you can math frac it back into a fraction that's reduced, and it'll end up being -3 over 2. And one thing I got to talk to you guys about is that this fraction right here is negative, and it doesn't matter where that negative is. So I need you guys to understand that -3 over 2 is the same thing as 3 over -2, which is the same thing as putting the negative in front of the fraction and having 3 and 2 not be associated with that negative. All right, all of those are exactly the same thing. What you can't do is you can't take that negative and put it with the 3 and the 2, because if you have -3 over -2, that's actually a +3 over 2. And then that fraction's positive, whereas the fraction that we have for our slope here is negative. So be very careful, okay, with the negative. If you only have one, it can go with the numerator or the denominator or out in front of the fraction, but it cannot go both with the numerator and the denominator, because then that makes that a positive fraction. All right, and just to show you guys what this slope means is that because this 3 on the top here is a rise and the 2 on the bottom is a run, what they're doing is to rise 3 down, we're going to go ahead and start at A instead of B and rise 3 down. And the 2 on the bottom is run, and it's positive, so we run to the right. And you guys can see that you'll end up on your line by doing the slope of -3 over 2. If I go down 3 more and run 2 more, you guys can see that I get to my endpoint there. All right. And so that is what the slope means. It's the rise over the run, and it tilts the line a certain amount. Okay. All right. Let's go ahead and do part B. So in part B, we have C, who is at -2, -6. And then we have D, who's at +4, +2. If we go ahead and connect those 2 points, we get another line or a line segment. And it is a different tilt than our blue line segment. And so therefore it will have a different slope. In fact, this line is going up as we read it from left to right. So our slope should come out positive, whereas our blue line segment was going down as we read it from left to right. And so that's why that slope was negative. Okay. All right. Don't forget our formula, guys, is y's to the sky. So the y's are on top. And so technically you can start with either y value. I'm going to start with the -6 y value, and then I'm going to subtract my other y value, which is 2. Okay. Because I chose that order on the top, I just have to be consistent and choose the same order on the bottom. So because I started with this y on top, I have to start with this x on the bottom. And so then I have -2 minus my other x value, which is 4. Okay. And then I'm going to go ahead and clean up the top. -6 minus 2 is -8. And on the bottom, -2 minus 4 is -6. And because I have a negative divided by a negative, I don't have to worry about them anymore because that makes the fraction positive. Okay. And all I have left is 8 over 6. But I told you guys slope has to always be reduced. And so if you don't know how to reduce that, you could type 8 divided by 6 in your calculator, hit enter to get the decimal, and then math fracket to get the fraction back in reduced form. And that's going to be 4/3, okay, which is really just dividing both the numerator and the denominator by 2. Okay, and there's our slope. And so if we want to talk about rise over run, so we can see what 4/3 as a slope actually means, it means that we're going to be rising 4. And since we're going to be rising, we're going to start at C to do the rise. So rise 4. And then 3 is positive. So we're going to run 3 to the right. And notice you end up on your line. Okay. And so we're going to go ahead and rise 4 again and run 3. And then we end up at D. All right. And so that's what slope actually means. So if we left the slope as 8, 6, we would rise 8, run 6, and we would end up going from C right to D without doing that middleman in the middle there. Okay, but slope should always be reduced, especially when you're writing the equation of a line with the slope in it. All right, let's take a look at number 2. Number 2, part A says that on the accompanied grid, we are going to graph label triangle ABC, who has coordinates at A, which is at +2, -6. Put a dot, call it A. B is at +6, -3. Put a dot, call it B. And C is at +9, -9. Put a dot, call it C, and go ahead and connect your 3 letters to get your triangle ABC. All right. Part B says on the same grid, graph and label and state the coordinates of triangle A prime, B prime, C prime after the transformation of T, -6, 8. And -6 comes first, and so that is always referring to the X coordinate, and it's referring to going either left or right. And because this is a -6, we are going to the left 6. 8 comes second, so 8 refers to the Y coordinate, which goes up or down, and this is going to be 8 up since 8 is positive. All right. What we can also do, instead of moving each one of our points left 6 and 8 up, we could go ahead and subtract 6 from all of the X coordinates, which will actually move them 6 units to the left. And we'll go ahead and add 8 to all the Y coordinates to move our Y coordinates up 8. And so now we'll have A prime, which will be located at whatever 2 minus 6 is, which is -4. -6 plus 8 is going to give us a +2. B prime will be located at 0, 5. And C prime will be located at 3, -1. Okay, and then we can go ahead and graph our new triangle. So -4, +2 will be where A prime is. B prime will be at 0, means no left and right, 5 up. So 0, 5 is right here. And 3, -1 will be right here. All right. And so our triangle should be the same shape and the same size, since translations preserve the distance between points and the angle measure, keeping the size and the shape of the figure the same. Okay. Also known as a rigid motion. Okay, and I believe that's all we have to do for part B. So we're on to part C, and they want to know what is the slope of the vector that describes the translation. So if you remember vectors are a line segment that have a length and a direction. So for instance, if we were to draw our vectors in, we would start at our original point of A, and we would connect it to A prime, which is where it went. So that's the size of the translation. And I'm going to put an arrow here, and that gives the direction of the translation as well, what direction we slid our shape in. All right, we're going to do the same thing, or we could do the same thing if we wanted to, but all of these should be the same length and in the same direction. So this would be the vector here going from B to B prime. And then this here would be the vector going from C to C prime. Okay. But notice all of those vectors are in the same direction. They're all parallel to each other, and therefore they're all tilted the same, and therefore they'll all have the same slope. So we really only need to look at one of our vectors and figure out what the slope of it is, or how it is tilted. Okay, so I'm going to go ahead and look at this vector here that goes from A to A prime. Okay, so it's basically just a line segment, just like we had up in number 1, and we're going to calculate the slope. Okay, so basically I am looking for the slope that goes from A, which is at 2, -6, to a prime, which is at -4, 2, there are my 2 points, and therefore I can calculate slope, because slope, all you need to do is have those 2 points to calculate it. So we'll say slope equals, or m equals, remember, y is to the sky, so I'm going to have to take my y coordinates of those 2 points, and I'm going to take -6 first, and I'm going to subtract my other y coordinate from it, which is 2. Because I chose that order on the top, I have to keep the same order on the bottom, and so I'm going to have 2 go first for my x coordinate, then minus my other x coordinate of -4. Okay. All right, cleaning up the top, that's going to be -8. And on the bottom, those 2 negatives actually make a positive, and 2 plus 4 is 6. Okay. And if I reduce this, this is going to reduce to -4/3. Again, if you need help reducing fractions, use your calculator, please. Okay. And there's the slope of my vector. Okay. All right, I'll see you guys on the back side of notes.